that very little part got saved, okay? Almost nothing there. I'll probably discard that, but we'll pick up and go from here. So let's go from current slide and see if we get this back again. Okay, here we go. So, as we said, we now have 2/3 of the standard form of the quadratic function written. Y'all chose to name it y. Let me get my pen back. Okay. Y of x is equal to, do we have a yet? No. X, do we have h yet? 1. Minus 1 squared. Do we have k yet? 2. All we need is the a, right? All we need is the a. All right. Well, what else do they tell us? They tell us that the graph also passes through the point 3, -6. Okay. Now that does tell us a little something. Okay. Remind me? Johnson, got it. Tiana, right? Okay. All right. Does anyone else come in? I didn't acknowledge your name when you came in. I think I got you. Okay. All right. That's the one thing we haven't used yet, is that point. Is it 3, -6? Yeah. Did I copy it right? Yes. Okay. Now, what in the world does the 3 stand for? Oh, come on. I was going to say, this tells us a little something else. If the vertex is at 1, 2, and this point is at 3, -6, what does it tell us about the vertex? Ah, yes, the vertex is up and the function's going down. So what does that also tell us about the a? Negative. Okay, we expect that to turn out being a negative value. Let's see if it does. So now I go back. What does the 3 stand for in this point? An x value. And 6 stands for y value. And since y'all named the function y of x, that's pretty clever. Okay, so we'll say the y, which is -6, is equal to a. We don't know what that is, but we're looking for it. The x is 3 minus 1 squared plus 2. Right? That point is on the graph, so it must fit the equation. Right? So let's solve the equation for a. This will be a -6. I can do that. Times is equal to a times, and what's 3 minus 1? 2 squared plus 2. That would be -6 is equal to, what's 2 squared? 4a plus 2. Now what do we do to solve for a? That's what we're looking for. Subtract 2 from both sides. And that gives us -8 is equal to 4a. And what is a? Divide both sides by 4. And that gives us -2. A is equal to -2. Now we go back to our standard form and plug in the a. Y of x is equal to -2, good old negative a there, going downward, times x minus 1 squared plus 2. Done. That is our equation in standard form. A is -2, h is 1, and k is 2. Fits the bill. Okay? Now, in the book, they graph it for you. Okay? You want me to? Is it necessary? Yeah. Okay. I'll try to do it in the space I have left. It will go into what's there. So let's do the y-axis here. And we'll do the x-axis somewhere like this, okay? And let's tick off a few points. 1, 2, 3, 4, 5, 6, 7. We won't need that many. Okay? And go up, down. Okay. Now, and here's Reggie, right? Now, the bottom part of the alphabet, which is mighty sparse. So I'm glad you're here. Okay. So there's our graph. Where do you want to start graphing? 1, 2. Buckle my shoe. Okay. We go right 1 and up 2. Right there is our vertex. Kind of right in the middle of that parentheses. Any other points you'd like to graph? Well, why don't we do 3, -6? That's 3, -6. 1, 2, 3, 4, 5, 6. I just barely squeezed that in. So there's a second point. Now, what would be another thing that might be convenient to know? The what? X-intercept. That's a good idea. Now, you know, in this form, it's harder to do, but it's certainly, doable. How do you get the x-intercepts here? Is that what you said, x-intercept? Okay. What is true about that? Y is equal to 0 on the x-intercept. So if you put y equals 0 and then start moving things around, you could add 2 to subtract 2 from both sides. It's just I have a lot of room to work here. That's certainly a thing we could do. Let's postpone that for now. Something a little simpler to do that we can do. Yes?
Do the opposite of the point that we got.
Okay, what would we need to know, though? That's what I'm getting at.
It'd be -1, -6.
Okay, how did you get that?
Because it goes over 2 down 6.
From where?
From the vertex, not down 6.
Ah, okay. What goes through the vertex? What goes through the vertex? Axis of symmetry. That's what I was getting at. And what is it? What is our AOS? Okay, what one? X equal 1. Okay, that's what it is. X equal whatever your H is. So that's what I was getting at, and that's exactly, see, this is easy to do. And you see that's 2 on that side, so 2 on this side would be right there. Oh, let me get my pen back. Okay, right there. See, I'm a little too lazy to go too much work here, but that will certainly do. Okay, now, other points. I thought you were going to say the y-intercept. The y-intercept in this form isn't particularly easy, but it is doable. What's true about the y-intercept? X is equal to 0. So if you put x equals 0 here, this is a -1 squared would be a +1 times -2 is -2 plus 2 is 0. Hey, did we just find them both at once? Yes, we did, or at least one of them. So there's another point, 0, 0. Ha! Imagine that. Now, it's really easy to find the other x-intercept without doing much thinking at all. What do? Cross the axis of symmetry and put it right there. So we did find them, but this is a little bit easier than setting y equals 0. Okay? I didn't know it was going to be that easy. And that's all we can put here. So let's just go on and draw our, parabola. Something like that. See how that works? Not too hard to do. Vertex, easy to do. As soon as you get the vertex, draw the axis of symmetry, right? Smack dab through it, okay? Vertical line through the vertex. X equal H, okay? And then, they gave us 1 point. Using the axis of symmetry, we got its twin point on the other side. And then, y-intercept is usually a little easier to do because you just say x equals 0, do your calculations, and find out what the y-intercept is. And in this case, we just backed into the fact it's the same as one of the x-intercepts. Excuse me. And then once we had that one, we knew the other one because we just go across the axis of symmetry. And you got enough points to plot it. Yes?
The -2 makes the parabola upside down.
Yeah, it turns it down. The negative sign for the A You're absolutely right. Okay? Now, we kind of knew that already when we knew the vertex was up there, and that one point they gave us was way down here. We knew it had to be opening downward. So we were expecting that to be negative. And sure enough, it was. Okay, and speaking of negative, here is JT. All right. All right, good deal. Appreciate y'all coming in. It's a little on the early side. I'll get my watch out. Actually, pretty much on time. Okay. All right. Can't think of much else to do with that one. Everybody got it? Make sense? Good deal. All right, now we're ready for finding minimum and maximum values. Now, if we're talking about a quadratic equation, maximum exponent is 2, how does that always graph? Parabola. And guess what? You know what the maximum and minimum value will be? Say again? No, okay, one of them's going to be an infinity, and that's not really a value. So there's only going to be one absolute maximum or minimum, and what's that going to be? Yes, that's what the definition is. The vertex. That's always going to be your maximum or minimum point. That last one we did, it was a maximum point. Okay? Now, do we have to go through the process of getting it in standard form and finding out what the vertex is? Certainly that will give us our maximum or minimum. And how will we know whether it's a max or a min? Okay, we can see how it opens, but just looking at the equation, how do we know whether it's a max or a min? That A, what does the A tell us? If A is positive, it's it's a minimum. And if A is negative, it's a maximum. Okay? Got it. Okay, but we have to go through all that rigmarole to get it. We're going to go through a little bit of rigmarole first and find out a really easy way to get it without doing standard form. Okay? Now, this may be a little reminiscent to some of you if you ever went through the agony or the ecstasy of finding the quadratic formula. Remember that? Probably not. But anyway, let's go through it. So very similar to the same thing. In fact, it's almost identical. What we're going to do, how do you go about finding that standard form? Let's just do that. If you were given the function, I'm going to go back to our favorite old f's. F of x is equal to ax squared plus bx plus c. Okay? That's not the standard form for a quadratic function. That looks like the standard form for a quadratic equation. It's not quite. It would have to equal 0 to be the standard form for a quadratic equation. But it looks like that. So what was our process of going around about finding our HK? What was the first thing we did? Anyone remember? It's easier to do with numbers, but we got to do it with letters one time, and once we get it done, we're made in the shade, folks. What was the first step? Okay, remind me what our standard form looked like. Alpha of x is equal to a times x minus h squared plus k. Now what looks like, and by the way, are those two a's related? They're exactly the same numbers, okay? That's the key. First thing we got to do is factor out the a. Because it's factored out here, isn't it? So let's factor it out over here. But what do we factor it out of? The x terms, just the first two terms. A times blah plus c. Remember? We had the blank there. Okay. So when you factor out the a, what's left from the first term? X squared. Okay? Now, factoring is the same as what arithmetic operation? What did I do to ax squared to pull it out? Well, it's reverse of multiplication. It's division. Because if you're going the other way, you multiply. This way, you divide it. You divided ax squared by a, and that gave you x squared, right? So let's divide the b by a. So that would be plus b over a x. Ooh, I didn't leave enough blank, did I? Where's my blank when I need it? Okay, there we go. Okay, let me erase that one too. Okay, there's my blank. Okay. Now, what's the next step? Once you factored out the a, is that correct? Let's check it. Okay. By multiplying that. A times x squared is ax squared. A times b over a is bx, yes, plus c. That's exactly the same thing, right? Okay. Now, what's our next step? Say again? Okay, what do we do in the parentheses? Okay. Say again? Okay, not quite. Remember, if those were numbers there, we take half of that, the linear value, right? What we were calling b, take half of that. But now it's b over a. So, half of that would be b over 2a, right? Remember? That was the next step. Take half of that term there, that would be b over 2a, and then do what to it? Square it. So that would be plus b squared over 4a squared. We just added something to that, okay? Now, what did we add to it? Well, the a's out here, so that would be a b squared over 4a. So we subtract ab squared over 4a. Don't worry about that. We're not ever, I don't think, ever going to use that. But what we do use is this. And what did I tell you? As soon as you take half of that first number, that middle number, you could write it down here. Plus b over 2a squared plus this mess. C minus b squared over 4a. Don't worry about that. Okay? Now, that's our standard form. Here's the key, folks. This is what? Minus h. Exactly. That is your minus h, and there's your k. Who cares about the k? We do a little bit, but not much. Okay? Let me get your name, please. Okay. All right, good deal. Okay. Oh, and I do need to ask a favor of somebody. I got my watch out, but I seldom look at it. Huh? I got 9 minutes. Okay. We don't have much time. I have to leave at 9 o'clock. Sorry about that. Okay? Now, there's your h. H is equal to minus b over 2a. Right? Now, I started this of saying this is similar to what we did with the quadratic formula. Does anyone remember the quadratic formula? If this were equals 0, how would you find your x? X is equal to, anyone remember it? Minus b plus or minus. All right. Here's Dimitri. All right. I think somebody had a flashback. What was coming in there? Square root of b squared minus 4 ac all divided by 2a. All right. Now, I don't care about that other part. I keep saying I don't care about it, but I want you to notice something. This works for a quadratic equation, remember? That's when the graph is a parabola. Notice where you start. Minus b over 2a. And then you do plus or minus from there. That is the x for your vertex. Minus b over 2a. That's the h. So there's nothing new to remember if you just remember that from the quadratic formula. There it is. Whatever your middle term here is, the middle constant, over 2 times that, negate it. There is your h value. Without having to go through getting it in standard form or anything else, we've got it now. Just like the quadratic formula, you never had to go back and do it again once you remembered what it was or wrote it down. You had it, and you could just write down what your answer was with a little bit of manipulation. So the key is, that's the thing to remember. H equal minus b over 2a. Okay? So, that's what they're doing here. Many applications involve finding the maximum and minimum value of a quadratic function, which is going to be our vertex, by completing the square, that's what we just did, of the quadratic function, which we just did. You can write the function in standard form. They just went straight to this form without showing you how to do it. That's why I did it on the last slide. And you get A, that good old A tells us whether it's opening up or down, whether it's skinny or fat, you know, that's what the A tells us. And this is your minus b over 2a is your h, and that thing is your k. We're not really worried about the k yet. In fact, when we do need to know k, we just plug in h to the formula, and that'll give us a k, and we don't have to do c minus, remember all that mess. Okay? That's our standard form. The key to it is the vertex is going to be the maximum minimum, and it will be at minus b over 2a, and then to get the k, don't mess with that other mess that was out there, a b squared over 4a, you know, don't have to remember that. Just plug in what your h is to your function, and you'll get the k value. Pretty easy to do. So the maximum and minimum values of quadratic functions will be, consider the function f of x equal x squared plus ax squared plus bx plus c. Standard way they usually write it, but it's not in standard form. As soon as you see this, do minus b over 2 times a, you got the vertex. There's your h right there, without doing anything else, okay? And then plug that in here, put that value of x in, okay? And that will give you your k, okay? Now, when this a is positive, what is your vertex? Yeah, but the vertex is your minimum value, okay? And when a is negative, the vertex is the maximum value. And there it is. The minimum is at this value for h, x, and that is your h, and the value for it will be your k value. And, you know, if this a is negative, then this will be your x, your h, and that's where the minimum occurs, and the value of it will be whatever you plug in, the k. So, without having to set up standard form and doing all that, just write it down, minus b over 2a. That's all you have to remember, and it's straight from the quadratic formula as well. Okay? Now, I'm guessing, do we have time for example 5? What do you think? Huh? 3 minutes. I don't think we're quite going to make it. Sorry about that, folks. Okay. Yeah, okay. Y'all are just really kind to me, aren't you? That's what you're trying to impress me with, how you care about my not being sorry. Okay, I got it.
We want you close to the document.
Yeah, you really do. That sounds really good. We'll be fine. Okay, we'll start next time at example 5. We didn't get a lot done, but let me review for homework exercises. I would do all of 5 through 8. You'll only find the answers in the back for 5 and 7, but they're fun to do. Do 5 through 8, and calccheck.com got 5 through 8 too. then do either 9 or 11 or both. They're both at Calc Chat. 9's at Calc View. Do any of the odds 13 to 25. They're all at Calc Chat. 17's at Calc View. Do any of the odds 27 to 33. They're all at Calc Chat. Do 35. It's a Calc Chat. Do any of the odds, and this is one like we just did today, 37 to 45. They're all at Calc Chat. 37's at Calc View. And then this is another one like we did today, only it's visual. Do either 47 or 49. They're both at Calc Chat. If you want to try to do 51 to 55, they say using technology. You can do it without technology if you want to. And then 57 through 61, I think you can do. I know you can do it, but try to do those. They're all at Calc Chat. 57's at Calc View. And then there's 63 or 65. Do either one of those or both, and they're at Calc Chat. And 67 is a pretty interesting problem. But that's more like the one we're going to start with next time, so you may want to hold off, and after we do that last example, then you can pick those up. Okay? Now, some people haven't turned in. I think I'm preaching to the choir here, so I think probably all of you haven't turned in your first quiz. If you haven't, please get those to me. I'm also talking to people listening. I hope they're listening. And then if you haven't finished your first test, and a lot of people left some blank, so if you want to come back and do those, please come and see me and get those finished. I've got some of them marked, some of them I don't have marked, but come and see me and get those completed. I'd like to return papers to people, but I can't until I get them all in. So, good deal. Now, Thursday, we'll be here, 8:15, remember? 8:15. We'll do Thursday and next Tuesday. That'll make up the 45 minutes that we're going to miss today because of my doctor's appointment. All right, take care.
I sent you an email to see when it was time I'm going to finish my test.
Okay, when do you want to do it? Okay, I'll be back from my doctor's appointment sometime around noon. I don't know whether it's going to be before noon, afternoon. I don't know how long because I don't know how long waiting is going to be. But I'm free until 3:15, so anytime between noonish and 3:15 is fine with me.
You'll be in this class or
No, I'll be probably down at my office. Okay, 265. You know where that is across from the orientation class?
Yeah.
Okay. Between sometime around 12ish and up until 3:15. I got a class starting at 3:15.
I've got a quick question for you. So,
Okay.
I know that you put this on YouTube.
That's too slow. No, I'm just kidding. Go ahead.
So, I know you put it on YouTube and all, but I'm curious if you, edit it any before
No.
you put it on YouTube? Okay.
Unfortunately, I don't.
Okay, so you use is that application free for
Oh, yeah.
laptops and stuff?
Is what?
Is the screencasting free for laptops and stuff?
Oh, there's a screencast-o-matic. No, you pay for that. The school pays for that.
Gotcha.
But it's pretty cheap. You can tell it's a pretty cheap program.
Okay.
The one we used before was called Tegrity. It's a much more powerful program, but it's a lot more expensive. The school doesn't want to pay for it anymore. But yeah, Screencast-O-Matic has a cost. It's not a huge amount. Actually, it does have a free package. You can do, I think, 10 or 15 minutes freebies. But to do anything longer, you have to pay for it.
Oh, okay.
Yeah. Yeah.
Okay, me and my friend were thinking about starting a YouTube channel. So
Oh, yeah. Okay, well, if you're limited to 10 to 15 minutes, yeah, you can do it.
All right.
I think so, anyway.
Thank you.
Uh-huh.